Hi, thanks for checking our channel here. This is going to be a how-to test repair video on a old style Gallagher M800. This is probably one of my favorite fence chargers out there, made by any brand from any generation. This is a really solid built unit. This thing looks really nice for being this is a 98, so 1998 model. This thing looks really nice. It's a little dirty, but man, it looks nice for being 23, 24, whatever years old. So looks really nice. This is a pretty neat looking unit. I love these things. These old Gallagher 800s. I mean, any model of Gallagher from this 90s, early 90s, early 2000s stuff was really good. They're getting slimmer on parts. They're slowly discontinuing stuff, but we can still rebuild boards in this thing because it's old school, and we can get capacitors for them. We can retrofit transformers into them. There's not much we can't do to this thing to bring it back to life and make it run like it's supposed to. So that's our information right there if you didn't catch that. Our address right there, what we do, who we are, where you can find more out about us. So we're gonna I love these things because what's nice about them is, well, once you understand how a fence charger works and how one of these things works, everything's all separated. And on the inside, if you know what it's doing or not doing, you can always figure out which area to tackle first for troubleshooting. So now it doesn't come on at all. It does have a fuse mount down here at the bottom, so we'll undo the fuse here real quick. It's not common just for a fuse to be bad, but let's check the fuse. Some of these had fuses, some of them didn't. But we'll check the fuse real quick. It's the quickest thing to do. Go across continuity and see if it beeps at us. Alright, fuse is good, but still doesn't come on. So, only two things. I didn't see the green light lighting up, so that's the power light over here. It tells you, hey, power's on. So I didn't see the power light coming on. This has got the stupid screw on the front there, so we'll get the special bit to take the screw off. That's what it kind of looks like. Take this back cover off. I've worked on so many of these things, it's not even funny. But they sold thousands of them, millions of them. I don't know. They sold a lot of them. They were around from the mid 80s to the early 2000s, so they had about a 20-25 year run with the thing. Ooh, look at the board. It's got moisture in it. So how do I definitely keep it from running? So what most people wouldn't end up doing is just throw a new board in there and call it done, which we may end up having to do. We'll see. We'll check a few things on the board. We can take this capacitor off, solder another one on. This is not a this capacitor itself isn't available, but we can put something else in its place. That'll be just the same. Might have to drill some holes in it, whatever. Check the capacitor first. Check your capacitor. Look at your meter. If you got, I have a Fluke 115, but not every meter can test capacitors. Its symbol for it is right there, a yellow symbol right there. It's not ohms, not resistance, not continuity, not a diode. It's this little yellow symbol right there. This is a either a 30 microfarad or a 40. The early ones were 30s and later ones were 40s. So I don't know which one this one is inside here, but let's pull this strap off here. 40. There's no polarity to it. 31.5 roughly. So capacitor's a bit weak. Probably original to it. Let's check a few other things on the board, and we'll We'll probably go ahead and replace that capacitor on there. Check this thing over here real quick. Alright, well that's one reason why it didn't come on, is that piece right there. But this big resistor itself, is it bad? Did it freaking read? Come on. Sizes. Alright, it is a 100 ohm, read 100 ohms. Alright, so let's we'll do two things first. We're going to change up the thermal cutout as well as the capacitor. We'll redo that as well. So let's go ahead and we'll pull those off first, since that's the first thing we need to tackle with it. So we'll go over here first to the thermal cutout, pull it off. And this is a protection piece to protect the unit. Shuts it down basically when that resistor gets to a certain temperature threshold. It shuts the thing down, burns itself open, then you have to replace that component part. I'm going to suck the solder off this capacitor here, and we'll pull the capacitor off. Capacitor might be good, I don't know, but it's been water, moisture, or something's gotten to it, corrosion. I don't want to take a chance on it, so we'll desolder and solder another one on. Not a big deal. It's got to hopefully be able to get all the solder off the thing, because it's got some crap built up. Got some crap built up on there on this side. Come on. Alright, so let's first pull this little metal thing off. Thermal cut off there. Let's see if we can get this capacitor off next. I need a small flat screwdriver. That one's off. Okay, there it comes. Okay, so it should just pop right off there. Feels pretty light, so probably not wore out. Alright, I'm going to find another capacitor and get the thermal cutout as well. Alright, got a new capacitor, different shape and style, but it's same. It's actually a little bit bigger, microfarad wide, but same voltage capacity. You got the thermal cutout right there. So we'll put the thermal cutout in first, because that's the easiest thing to do. Because this capacitor, we're going to have to drill some holes and probably put some glue on it or something to keep it in place. But we're going to put this thermal cutout in first. This has no polarity to it. I don't remember what size. There's a million of those thermal cutouts and styles, but because they're temperature rated, and there's a lot of different ones have different temperature ratings and stuff like that. So you can't just put any old one in there. You got to put the right one, or to get too hot too quick and shut down prematurely. Oh, come on. Put the strap over the top of it. We'll go ahead and solder that back on and get it done. Snip off the excess when we're done. Okay, that's good so far. I mean, there's this. We'll have to check this. Well, we'll turn it on first when we get this capacitor changed out. All right, I need to get a drill, small drill bit. figure out where this needs to sit at. Sit right there. All right, we're going to drill a hole right here. So that sit right there. So we get the two holes drilled out, one there, one there. Should hopefully sit right inside those two holes like that, and just come right on through. Alright, so now what I'm going to do is I'm going to get something underneath this to help prop up the capacitor to keep it in place. And then we'll run some wire to its corresponding spots it needs to be at. Because those little terminals, leads that are on that capacitor are way too short to reach anything. At least in this application they're too short, so we're going to add a little solder here, add a little solder there, strip off the end of this wire, add some solder to this. Snip off a little bit, maybe a little too much exposed. And then we'll heat up. We'll do this one first. Heat up the two connections, the wire and the little lead coming through. And we're just going to run it over to there. Because electrically it's the same spot. Strip off a little bit here. And we'll repeat the process. We'll add a little solder to this wire and put it on that terminal there. Blend these two together. And then we're going to run it over to there. Strip off the end. Oh, going for a ride. Alright. Let's see, we'll add a little solder here just to give it a little more surface area to work with. And we'll run that over here and heat the two up together. We'll add some solder here. We'll heat those two up together. That doesn't wobble too much. A little bit, but not that bad. Might put a little goop right there to hold it in place. So electrically, it's all the same spot. This area was soldered over to here. This is soldered over there. It's electrically the same spot. Before I glue that thing in place, let's go ahead and slide this back down. And so now what should happen this green light should come on. It should click, and every time it clicks, this light should flash. So let's turn the light off so we get rid of the glare. So let's see what happens. Alright, well, that light's not flashing or barely flickering. Let's test the output. Well, it shows 8,000. Why isn't that light flashing? I've got boards here in stock, but let's see if we can. Check this out. Okay, so solder is right there. This bulb does. So something that's feeding it is probably shorted out. Let's try this big green resistor first. It says it is a 10 watt 10k ohm. So check. So it should be 10,000 ohms on the reading. So we're gonna check across that first. 10k on the dot. All right. Look at that resistor real quick. I don't know what size that is. I can't find my little wheel. It gives me the. Oh, there it is. On my little resistor cheat code thing here. Alright, so it's like brown, black, yellow. Brown, black, yellow. So it should be 100,000. 100K. So imagine some of these diodes are probably all bad. That one's good. 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 Shoot. Okay. What about this big old resistor over here? 820 ohm. 810. This won't matter. This is a voltage splitter one. So yeah. So I imagine either these orange things have got problems or this little capacitor is bad. I don't have a capacitor that size. I don't think. Maybe. Let's see. Let's see what this one is. I think it'll work. I think we can try it out. See what happens. Take the capacitor off, and then we'll oh, I didn't even see that. Yeah, it's bad. See, it's cracked. I didn't realize that. So that capacitor is definitely no good. Alright, so we'll put this capacitor right here in. This should work. Cut off the extra. Still got to do a ground fault test on it, which I'll do that as soon as we get this thing flashing right. We can do a ground fault test on the transformer and everything inside. Make sure it passes those tests. Light off. Get rid of the glare. Plug it in. Oop. Oh, I bent the tab over. Whoops. I did it again. Come on. Clean up a little bit, make sure it didn't arc me. Can't see. Oh, there we go. Try this again. Put another bulb across that real quick. See if the bulb flashed. Maybe the bulb's just burned out. I think we just got a burnt out bulb or a bad connection or something on the bulb, because I put another bulb in the line there and it starts flashing and flickering, so I think we got a bad bulb. Let's take a closer look at it and see. Oh, a little corrosion right there. Right at the base there, so probably not making a connection enough to make that that little bulb flash. See the corrosion right there, a little green crap built up on there, so alright, well, got the bulb in stock, so let's change it too, so that way it's functioning. Alright, that's nice and clean. Solder, where are you? Alright, now try it again. Hopefully it didn't mess nothing up. Still working fine. Bend them tabs straight. These tabs are kind of cockeyed, crooked, and bent back out of whack. Alright, try this again. There we go, light's flashing. Let's do the ground fault test. I got my wire tied to my ground outside. Run this wire from the ground side to here. Should still flash. Hold on. The only thing I'm still gonna put is I got to put a new capacitor in there, but voltage wise, it's sitting at a little over 7,000 volts out of it, so that's right where it needs to be. We'll put a wire across it so you can see the spark jumping from it. Alright, well that one's done. Took a little trial in there to get that output board right. We got to put a new capacitor in there, but that's not a big deal. It's pretty straightforward. So we'll call this one done here in a minute and move on to the next one. I put a little glue on there to keep that capacitor secure in place. Alright, well have fun out there, and got any questions, get a hold of us. Bye-bye.